Hello, good evening everyone. I hope everyone is doing great. So in today's lecture, we are going to continue hydrograph topic. Okay. So good evening, Sushil and everyone. Everyone kindly comment that I am fully audible and visible to you all. Then I will start the lecture. So today is your lecture number. Today is your lecture number 20, I guess. See, in last class, basically what we have discussed. First, let us discuss the topics of your last class. In last class, sir, you told me, sir, in last class you told me about the basic things of hydrograph. Okay. Tell me that I am fully audible and visible to you all. Then I will begin. Sir, you told me that in my catchment area, if I am giving input as rainfall, then what will the output? Output will be the discharge versus time graph at outlet. At outlet of catchment, we will draw a discharge versus time graph, which is known as storm hydrograph, or flood runoff hydrograph. Okay, this thing we have discussed. Rainfall duration is very less, but you will see that its effect will be longer. Rainfall durations effect will be longer as compared to your rainfall. Okay, effect will be longer. That effect, total effect which remains there, is known as base time. Okay, I told you that runoff takes place in two forms. One is your direct runoff, next one is your base flow, that is diluted flow. This is your quick flow. Sir, quick flow is the effect which takes place immediately after rainfall, within 1 or 2 days or 3 days or 4 days, like that. So the effect which takes place quickly after the rainfall, that is known as direct runoff, and we are interested in that hydrograph only. So this flood runoff hydrograph basically will indicate rainfall and catchment characteristics. Yes or no? So this you need to understand. Okay, sir, no problem. Now what else? Sir, you told me that from this hydrograph, if I will separate the base flow, if I will remove the base flow, I will get a direct runoff hydrograph, which is also known as DRH. And FRH ordinate will be given by DRH ordinate plus base flow. You all know this. So DRH indicates basically immediate effects. Okay, as soon as your rainfall ends, you need to understand, as soon as rainfall starts, basically you will see that some water will start reaching your outlet immediately. Okay, and more and more water will reach your outlet. As more and more water will reach your outlet from farther places, you will see that the peak, it will result into the peak of hydrograph. Okay, so when contribution of entire area increases, then you will see that outlet discharge also increases. So these are the quicker effects. DRH will indicate quicker effect. Then you told us about, sir, a simple storm, sir, in which only a constant rainfall intensity is there. Then you, sir, told us about complex storm, in which many other intensities are also there. Okay, so this was clear to me. And how we calculate runoff depth, how we calculate excess rainfall, how we calculate effective rainfall depth, that you have told me. Sir, I will simply use what? I will simply use the formula precipitation minus infiltration. Sir, this is very, very clear to me. Then, sir, at the end, you told us about the components of hydrograph. Okay, sir, this was the rising limb or succession limb. This depends both on rainfall characteristics as well as catchment characteristics. Sir, this was the crest segment. Sir, this was the falling limb or recession limb. Sir, this point G2 was the center of hydrograph. This point G1 was the center of rainfall. The time gap between G1 and G2 is known as lag time. TP is known as time to peak discharge. TL is time lag. TB is base time. The effect of quick runoff. Okay, after rainfall, the effect of quick runoff. Okay, the effect of quick runoffs, you can say, stays for time TB, because this is your end of direct runoff. Okay, E indicates end of direct runoff. So I hope all the points which I have told you, the segments or the components, are fully clear to you. This B and D point are point of inflection. Okay, so this is the hydrograph which has resulted from an isolated storm. Here we have a single storm. Okay, this has come from this portion. I have already told you, we have written, see, this is indicating excess rainfall, how much water or how much rainfall is available for runoff. Okay, this is indicating that. Okay, Manjusha is saying, please repeat lag time. Okay, Manjusha, listen very carefully. You need to understand what lag time is. So we have to understand from the very basics. Listen, Manjusha, just imagine that this catchment area is receiving rainfall for 2 hours uniformly. Okay, sir, no problem. Now, if I want, now, sir, what, see, if I want to find the center of rainfall, see, this duration is 2 hours. If I want to immediately drop this entire rainfall in the entire catchment area, I will drop it at 1 hour. Okay, see, average of 2 hours is average of 2 hour is 1 hour. Okay, 2 hour average is 1 hour. So that will be your center of rainfall. That will be the center time of your rainfall duration. Exactly at 1 hour, sir, if rainfall occurs for 2 hours, exactly at 1 hour, I will drop all the precipitation that will be equivalent to that uniform 2 hour rainfall. Okay, sir. Now, because of that rainfall which has happened in 2 hour, because of that, sir, the peak value will come after some time, because water takes some time. Sir, water takes some time. This area will contribute to the outlet discharge, but it will take time. Yes or no, Manjusha? It will take time. Yes, sir, it will take time. Now it is taking time, sir. Since it is taking time, I will say the peak will come after some time. So the time gap between rainfall and between your peak, the time gap between rainfall and the peak to occur basically is known as lag time. And why lag time is there? Because, sir, water will for sure take some time to reach the outlet. Water will take some time, yes or no? So that is lag time. Is this clear? Sir, water takes some time to reach your outlet. So for peak to occur, some time will be taken by your catchment. See, the bigger the catchment area, the more time water requires to reach the outlet. And lag time will be more. Yes or no? And lag time will be more. Yes. So this time and peak time gap is known as lag time. If catchment area is smaller, you need to understand, you can write the significance. If a smaller catchment area is there, lag time will be less because water will reach immediately. And if you have a bigger catchment area, then obviously lag time will be more. Okay, sir. So this is it. Now the relationship between lag time and TP is, you can see TL is from center to center. So this is what? This is D by 2. This is total TP. So from TP, when you will subtract D by 2, you will get TP. Okay. Yes, so this is the relation. TL is equals to TP minus D by 2. So all these things we have already discussed yesterday. And at last we have solved one question. Okay, we have discussed what DRH was. Okay, we have discussed DRH thing. So DRH was nothing but FRH minus base flow. Okay, so FRH data was given to us in the question and a constant base flow of 5 was given to us. We have subtracted and we have got the DRH value. So I hope this thing is clear to you. Okay, now today we are going to start our lecture number 21. This is our lecture number 21. We are going to discuss the factors. We are going to discuss the factors which will be affecting my hydrograph. Okay, so can you guess what factors will affect? Can you guess what factors will affect the shape of hydrograph? Okay, can you guess it? So in today's lecture, basically we are going to discuss factors affecting hydrograph. We are going to discuss base flow separation. Okay, we are going to discuss effective rainfall depth from FRH. These are the topics which we are going to discuss today. Okay, sir. So let's proceed and start with the topic factors affecting your hydrograph. We will discuss the topic factors affecting hydrograph. See, you need to understand one thing. See, the factors which will be affecting your hydrograph are rainfall and catchment characteristics. Okay. Yes, sir. See, there are some physiographic factors. Sir, there are some physiographic factors for sure which will affect. There are some physiographic factors such as, okay, sir, there are some physiographic factors and there are some climatic factors. There are some physiographic factors and there are some climatic factors. I will explain it to you beautifully, but very, very small concepts have been asked in your examination from this topic. Okay, they will ask you if shape is this, what will be the effect? If shape is that, what will be the effect? If your catchment is round in area, how this will affect the hydrograph? So all these things have been asked. Okay. Okay, now the first thing is obviously your basin characteristics. Okay, obviously the shape of hydrograph will depend on catchment characteristics. Okay, how your catchment is. Is your catchment big or is your catchment small? Basically, we are interested in size. Okay, sir, size of catchment will affect. Sir, shape of catchment will affect the shape of hydrograph. Okay, so this hydrograph will be influenced. This hydrograph shape will be influenced by the size of catchment, by the shape of catchment. Okay, what is the nature of valley? Okay, what is the nature of valley? Okay, I hope you all know what valley is. In the see this catchment area thing. In this catchment area thing, see This portion is at a higher elevation and water flows down along the side slopes to the valley line. This is your valley line. See, catchment concept I have already explained in, earlier in this hydrograph topic. Okay, so this is your valley line and this is your ridge line. So this is valley. Valley means V shape. So this is a V kind of shape. This is a V kind of shape. So this is your valley. Okay, I hope this is clear to you. You can imagine we have mountains on both sides and a river in between. That is valley, V shape. Yes or no? So based on the nature of valley, your hydrograph shape will change. If you have a steep valley, the hydrograph will rise quickly. Yes or no? The hydrograph will rise quickly. If you have a gentle valley, obviously the hydrograph will rise less steeply like that. Okay, so obviously the physiographic factors, that means physiographic factors such as size, shape, nature of valley of catchment will affect all these things. Okay, then what is the elevation? What is the elevation? Okay, what is the elevation of your catchment? Then what is the drainage density there? Okay, we'll discuss all the factors one by one. We'll discuss the most important factors one by one. Okay, obviously not all, because not all are important. So these are the you can say physiographic factors of catchment. Okay, basin, how your basin is. If you have more drains, the flood hydrograph will rise sharply. If you have less number of drains, drainage density means what? Drainage density means more or less number of drains. Okay, if drainage is more dense, then obviously water will reach your outlet very quickly because drain network is proper. Then sir, after this, sir, we have infiltration characteristics. Then sir, after this, we have infiltration characteristics of your catchment. See, listen very carefully. If you have less infiltration, then obviously runoff will be more. Yes or no? Sir, if infiltration is less, then runoff will be more. Okay, so obviously this depends on sir soil type. Okay, sir, this depends on soil type. What kind of soil we have in that catchment area? What is the geological condition there? Okay, do we have forest in that area or not, or is that a fallow land? So many things are there which will govern the shape of hydrograph. Then what kind of land use is there? Okay, forest area or city area. Okay, what kind of land use and cover is there? So because land use pattern will significantly influence runoff, and if runoff is influenced, then obviously the shape of hydrograph will change. Okay, the shape of hydrograph will change. Then are there any lakes? Are there any swampy areas? Are there any lakes, or are there any swampy areas, or any kind of other storages in your catchment area? Because you need to understand. So let us say water is flowing down and joining the main river. Okay, and reaching your outlet. Now let us imagine we have a very huge lake or a very huge storage here. So when rainfall will happen, what you will observe, that huge amount of water or huge volume of water will store here in this lake. Let us say we have a very big storage, or let us say we have a very big lake. So obviously after rainfall, huge amount of water will collect in this lake. And if huge amount of water will collect in this lake, then obviously the water which will be reaching the outlet will be less. And then in that case, you will see a very moderate kind of hydrograph. And if this lake was not there, then you will see a sharp, or you can say you will see a hydrograph which has a higher peak, because more volume will reach there, because more volume water will reach there. Yes or no? So many things are influencing the shape of hydrograph. Many things, sir. If storage is there, the hydrograph height will go down. Okay, so many factors are influencing your shape of hydrograph. Okay, then what else, sir? Channel characteristics also. Channel characteristics will also influence the shape of hydrograph. Okay, channel characteristics means what is the cross section of your river. Okay, what is the cross section of your river? See, cross section also influences the discharge. If we have a perfectly circular kind of cross section, then obviously runoff will be faster. In that case, discharge will be more. Okay, so cross section, roughness, okay, roughness of channel, more the roughness, lesser is the discharge. And what is the storage capacity of channel? If your channel has huge storage, then obviously water reaching your outlet will be less, because channel will store more amount of water. Okay, when channel will store more amount of water, then obviously discharge reaching there will be less. Okay, so obviously all these factors will influence your shape of hydrograph. Then we will discuss the climatic factors. Okay, then we'll discuss the climatic factors. So first is, in climatic factors, the first is what kind of rainfall we have. That means the storm characteristics. Okay, so the first one is how much precipitation your catchment has received. How much precipitation your catchment has received. What is the intensity of rainfall? Is your rainfall more intense, less intense? If more intense, then obviously this graph will rise sharply. If less intense, obviously it will be, you can say, mild. Yes or no? It will be mild. Sir, intensity of rainfall, how much total volume of rainfall is there? Then how long your rainfall has lasted? What is the duration of rainfall? On that also your hydrograph shape will depend. Okay, then what is the magnitude? What is the magnitude? What kind of precipitation? Is there snowfall or is there rainfall? You need to understand, if snowfall is there, it will take too much time to melt. Okay, it will take too much time to melt, and after this melting, runoff will take place. And after this melting, runoff will take place, and obviously your outlet will receive discharge later. Yes or no? So what kind of precipitation we are receiving? What kind of precipitation we are receiving? The shape of hydrograph will be dependent on that. Okay. So precipitation, intensity, duration, magnitude, all these things are there. Then we have movement of storm. Then we have, sir, then we have movement of storm. How your storm moves, this I will explain, so don't worry. Then we have aerial distribution of storm. Aerial distribution of storm. We have aerial distribution of storm. So many factors are there related to your storm characteristics. Okay, storm characteristics. Then we have initial loss. Okay, climatic factors, these are all your climatic factors. Initial loss, initial losses can be more. See, if initial losses are more, obviously runoff will be less, and if runoff is less, then obviously your flood hydrograph will be mild. Yes or no? If runoff is less, then obviously your flood hydrograph will be mild. Okay, so these are your initial losses. Then we have evapotranspiration. So all these initial losses and evapotranspiration are losses, and it will, if they will increase, then obviously they will reduce the runoff significantly. So these are all the factors which will affect my hydrograph. Now we will discuss some of the important ones, how they are governing exactly the shape of hydrograph, that we have to discuss. Okay, so before that, tell me if you have written all them. Before that, tell me if you have written all of them. Okay, now we'll discuss now we will discuss first the shape. Now we'll discuss everything. Okay, clear? Perfect, sir. Now we'll discuss the first factor. Now we'll discuss the first factor, which is your shape of basin. Okay, which is your shape of basin. Okay, so if we want to understand how shape of basin influences the shape of hydrograph, okay, see, we will take some different shapes of catchment, with the help of which we will be able to understand how, if the shape of basin changes or catchment changes, how it will affect my hydrograph shape. Okay, so let us imagine, let us say we have, this kind of catchment area. Okay, let us say we have this kind of catchment area. See, water is flowing from this end to this end. This is your outlet. Okay, this is your outlet. Let us imagine we have this kind of, let us say we have this kind of catchment area. Okay, okay sir, so water is coming down the side slope and ultimately joining your valley line and is going in this direction. Okay, let us say we have this kind of rainfall, oh sorry, catchment area. Let us say we have this kind of catchment area where sir, where you can see outlet is here. Again water is moving from here to here. Okay, what will the difference if shape changes? Okay sir, if shape changes, how the shape of hydrograph will change? Okay, and at last let us say, let us take this kind of catchment area. Okay, at last let us take this type of catchment area. So tell me sir, how exactly the shape of hydrograph will vary in all of them? Okay, how shape of hydrograph will vary in all of them. So let us draw three kind of hydrographs here. So for the first one, you need to understand, for the first one, let us draw three hydrographs here. See, we can see that shape of hydrograph is different in all the cases. Sir, the shape of basin is different in all the cases. Yes or no? It is different in all the cases. Yes or no? Yes, sir, it is different in all the cases. But you will see here, sir, little water. Sir, in this area, see, we are assuming one thing. Sir, what thing we are assuming? We are assuming that entire catchment has received uniform rainfall. Okay, sir, we are assuming that entire catchment has received uniform rainfall, which means, see, this portion will receive some rainfall. Obviously, this volume of water will be less, and this is a huge area. Since entire catchment has received uniform rainfall, obviously this area, obviously the you can say the area which is far away from outlet has received more volume of water. So that volume of water will take some time to reach the outlet, because that huge volume which is far away from the outlet will take too much of time to reach the outlet. So you will see in this case sir, you will see that flood runoff hydrograph increases. Sir, flood runoff hydrograph increases very slowly, because initially it rises slowly. Why? Initially it rises slowly. Why? Because, sir, only a small volume of water reaches, because this volume of water will reach first. Okay, but you need to understand, when this huge volume will come, it will rise immediately and a peak will come. But this peak will come later. Yes or no? But in this case, you can see huge volume of water which is being received by the huge area is near to the outlet. So what will happen here? Since it is near to the outlet, this water will reach earlier. So you will have a peak initially, and when this small water, or you can say less amount of water, will reach the outlet, in that case you will see the graph will diminish like this. So here we have peak which is delayed, and here we have peak which is happening at a quicker stage. Why? Because the more the amount of volume, okay, the more the area, the more the amount of volume which it is receiving by the rainfall, and it is reaching quickly because this more area is near to our outlet. The area which is more is near to the outlet. So that's why I can say that my hydrograph will increase sharply in the beginning. Okay, here, sir, it will increase, but it will increase sharply later, because this huge volume will take time to reach the outlet. Now what will happen in this case, sir? Sir, in this case, sir, I can see, sir, in this case what will happen? Sir, we have one huge volume here and we have one huge volume here, and in the middle, sir, less volume of water is there. So what will happen? First, see, the sequence is, this is at first sequence, this is at second sequence, this is at third sequence. First this will reach, then this will reach, and then this water will reach. Okay, ultimately the water has to reach the lowest portion, the outlet point. So when this water will reach, you will reach a peak. Now peak will start diminishing. Why? Because huge amount of water, when it will finish off, obviously this discharge will start to decline. But now this will reach. but now this will reach, and because of this you will see that graph becomes almost constant type. But immediately you will see that when this water will reach, it will start rising again. Okay, it will start rising again. Like this you will see the graph. So we have multi-peaked hydrograph here. In this case, sir, in this case we have multi-peaked hydrograph. So sir, you can say that shape of basin, sir, I can say the shape of basin will influence definitely the shape of hydrograph. Yes or no? Tell me. Yes or no? I think it is very very clear to you. If we have different shapes, of basin, obviously the shape of hydrograph will differ. Now one more thing. Have you written this thing? Have you written this thing? Tell me. So this is your shape of basin. Okay. Okay, sir. Now we can have two kind of catchments basically. Okay, sir. Sometimes we can have longer catchment areas. Okay, sir, sometimes we can have long catchment areas, long catchment areas, in which, sir, obviously long means when we have higher length. See, long and narrow. Okay, one kind of catchment is, see, we are discussing what, sir? We are discussing shape of catchment area. Sir, we are discussing the effect of shape of basin, the shape of catchment area. So sometimes, sir, we can have long and narrow catchment areas, but sometimes, sir, we can have, see, opposite of long is short, okay, and opposite of narrow is broad. So sometimes, sir, we can have short and broad, or you can say more or less circular kind of. We will write here opposite of long is short, whose overall distance is less, and narrow opposite is, narrow means we have width, less width, and here we have more width. So I will write broad. Opposite of narrow is broad. Okay, sir, in this one, in the first one, okay, sir, first let me complete the catchment here. Okay, first let me draw the drains also. These are the streams. Okay, sir, these are my streams here. No problem, sir. These are my beautiful streams here. This is the outlet here. This is the outlet here. Water has to ultimately reach here. Water has to ultimately reach the outlet point. Now, sir, in this one I can say length is more but width is less, and opposite case is length is less but width is more, but opposite case is length is less but width is more. Okay, yes or no? So we have these two cases. So can you guess, I just want to know, can you guess where we will have more peak discharge? Can you guess where we will have more peak discharge and where we will have less peak discharge? Tell me. Try to guess. Sir, long catchment area will take too much amount of time to reach the outlet. Yes or no? Sir, long catchment area will take too much of time. So I will say that in this case, base time will be more. And since base time is more, you need to understand water will reach slowly to the outlet. It will take too much of time. So the base time will be more. You will see the graph is like this, where we have more base time, and lesser peak. And here we have lesser peak discharge. Why peak? You need to understand discharge will be low because water will reach slowly. So in this case, I will have lesser peak discharge. But opposite to this one, since it is short, all the water will drain off quickly. In this one, water will drain off quickly. That means base time will be less. You will see that all the water will come down quickly. So here we have less base time as compared to this one, and peak is more, and peak discharge is more. Can you understand the difference between them? Tell me. Can you understand the difference between them? Sir, you are saying that when we have long and narrow catchment area, it takes too much of time for the water to drain off to the outlet. Yes or no? Okay. Is this in clear? Perfect. Perfect. So this is how your shape of hydrograph is different when you have different shapes. In examination, in your state engineering examinations, one question has been asked. Okay, one question has been asked about form factor and shape factor. See, form factor is a factor which will indicate what kind of catchment area shape we have. Okay, form factor is a factor or shape factor is a factor that will indicate the shape of basin. Okay, sir, you are telling me two factors. I will tell you two factors. The first one is your form factor. The second one is your shape factor. Okay, sir. These are two factors which will indicate the shape of basin. Now, form factor is indicated by, see, form factor is indicated by, okay, form factor is indicated by area upon length. Okay, form factor is indicated by area upon length square. Area upon length square. And reverse of this, and just reverse of form factor is shape factor. Length square upon area. Length square upon area. Okay, sir. See, let us imagine we have a rectangular catchment. Okay, this is B, this is L. So if you want to find the area is B into L, and this is L square. So it will be B by L. It will be B by L. Assume your catchment is rectangular. Assume your catchment is rectangular with length L and width B. So the form factor will be more or less equal to B by L. Okay, and here it will be L by B. Okay, so can you tell me in which of them form factor will be more? Will it be more in the first case or will it be more in the second case? Tell me form factor. Sir, form factor means almost ratio of B by L. So B by L ratio will be more in which case? Can you guess? B by L ratio will be more in first case or second case? Tell me. Sir, here in the first case, sir, length is more but width is less. Tell me, first case, second case, which will have more form factor? Sir, in the first case, you tell first, then I will write. In this one, form factor will be, tell me where we have more form factor and where we have less form factor. Tell me. Sir, form factor will be more when we have more width and less length. If width is more, form factor will go on increasing, and if width is less and if length is less, form factor is increasing again. Okay, so if we have more width, and less length, as it is indicated by second case, then in that case form factor will be more. And here in the first one we have less width and more length, so obviously form factor will be less here. Okay, form factor will be less here. Now what is the significance of form factor? Sir, you need to understand, if form factor is more, you need to understand one point. We have to make a note here. Listen very carefully. Okay dear, don't worry, we'll try to start. See, note down one point. Tell me, sir, if form factor increases, you will see that all the water will quickly reach to the outlet. If we have more form factor, that means if we have more area as compared to lesser length square, or if we have more width as compared to length should be less and width should be more. If width is more and length is less, then water will quickly drain off. I will write this point. If form factor increases, or let us say higher form factor will indicate what? Sir, higher form factor will indicate what? Higher form factor will indicate that water will quickly drain off. Water will quickly drain off from the catchment. Quickly means base time will be less. This one. Okay. Water will quickly drain off. This will be removed here. Yes. Water will quickly drain off water will quickly drain off from basin. Okay, so this form factor is indicating your this thing. Okay, yes SK, don't worry, already some playlists based on irrigation are there, so you can see that. Okay, some playlists are already there, so you can see that. Okay sir, so is this thing clear? Tell me, if someone asks you the significance of shape factor and form factor, can you tell the significance? Sir, form factor and shape factor are two factors that are indicating the shape of basin. Okay sir, this factor is clear to me completely. Okay, we have one more term, known as compactness coefficient. Sir, we have, okay, detailed is not there. See, you have to crack which exam? Tell me. Which exam you want to crack? The playlist which is there, it is more than sufficient. Okay, so don't worry. Okay, now I will tell you about compactness coefficient. See, this compactness coefficient, this coefficient will again indicate what? See, this coefficient will again indicate the shape of basin. It will again indicate the shape of basin. Okay sir. Sir, first tell me the formula for compact coefficient. See, compact coefficient formula is, it is the ratio of perimeter of catchment. It is the ratio of perimeter of catchment upon perimeter of form circle. Upon perimeter of form circle. Sir, what is the meaning of this? I am unable to understand this. See, let us imagine we have a catchment area. Let us imagine we have a catchment area. Let us say we have a huge catchment area like this. Okay sir, no problem. Like this we have a catchment area. Okay, this is the main stream in the center. This is your valley line, and obviously your water is reaching here like this. These are different tributaries of your main river. Okay, so this is the outlet point. Now, what you will do, you will convert this entire catchment area. Into a circle. Okay, I will convert this entire catchment area into a circle. Okay, but one thing you need to make sure, the area should be constant. See, if my catchment area is having an area of A, if my catchment area is having an area of A, then this circle should also have area of A. Now this circle is known as form circle. Okay, what is form circle? Sir, form circle means I will convert my catchment area into a circle, but I will make sure that area of main catchment area is same as that of circle. So that is form circle. Okay, you can call, don't worry. Okay, you can call tomorrow, no issues in that. Daily students call me, so no worries. Now, yes sir, what I was telling, yes, you were telling sir, this is what, yes sir, you were telling I have to convert my catchment area into a circle. Area is same. Now you see, actually you need to understand the perimeter. Let us say the perimeter of this, catchment area is P. Let us just assume the perimeter of this catchment area is P. Okay, let us assume it is P. So the formula will be P upon. Okay, let us say my catchment area is having area A. My catchment area is having area of capital A, and it is having perimeter of, let us say, capital P. Okay. Okay sir, now what I will do, I have to find the perimeter of this circle. You need to understand one thing. Sir, the area of circle is given by pi into r square. Okay, so when I will convert my catchment area into a circle, can you find the radius of this circle? Can you find the radius of this circle? Tell me. Can you find the, yes sir, obviously. So from this equation, I know the catchment area, I know pi value, I can find the radius of my circle. Yes sir. How? So radius of the circle will be under root a upon pi. Under root a upon pi. Okay. Radius of circle will be under root a upon pi. Now this radius will help me in finding the perimeter. This radius will help me in finding the perimeter. Yes or no? Tell me. Find the perimeter. So the perimeter of formed circle will be, the perimeter of formed circle will be, it will be 2 pi r. Okay, you know this, you know all these things basic. So it will be 2 pi and r is under root a by pi. Okay, so this pi and this thing will get cancelled and you will get 2 under root pi a. You will get 2 under root pi a. Yes or no? So I will write this perimeter of formed circle here, because compactness coefficient is perimeter of catchment upon perimeter of formed circle. Okay, so I will write 2 under root pi a. Okay, so this is compactness coefficient. See, basically you need to understand compactness coefficient is indicating how compactly your catchment is, you can say, distributed. See, if your catchment area is more of a circular shape, or we can say if it is short and broad. See, this is more of a circular shape. Okay, it is more, you can say, fan shaped catchment. This is fan shaped or circular shape, or you can say it is short and broad. So if you have short and broad catchment, okay, or if you have fan shaped catchment, all these are one and same. In this case, sir, you need to understand, in this case compactness coefficient will be tending to 1. Why? Because if you have perfectly circular catchment area, then the perimeter of formed circle and catchment will be same and it will be equal to 1. Okay, now if your compactness coefficient is way too far from value 1, if it is away from value 1, in that case I will see that my catchment area is more longer in nature, and in that case I will see that it is not a type of a circle. It is more, you can say, the shape is deviated from circle, it is more long and narrow, and obviously in that case I will see that it is not compactly arranged. This is not compactly arranged. If it is a circular form, then it is compactly arranged, and if it is not in a circular form, I will say that it is not so compact. And when it is not compact, obviously water will take too much of time to reach the outlet. Okay, so if your compactness, you can note down one point, if compactness coefficient reaches or tends to 1, if compactness coefficient tends to 1, it indicates that your catchment is circular in shape. If compactness coefficient values tends to 1, it will imply we have a fan shaped, or you can say circular shaped catchment area. That will imply a quicker runoff. Okay, we have fan shaped or circular shaped basin, indicating quicker drain off. But if this value is deviating, okay, if perimeter of catchment is more, okay, if perimeter is catchment is more than your perimeter of formed circle, then this ratio will go far away from 1. Okay, and when it will be more than too much more than 1, then obviously the shape of catchment will not be circular. Okay, so is this thing clear? Tell me. This is your compactness coefficient. So I hope this thing is clear. Compactness coefficient. So I hope the form shape of basin is fully clear to you all. Okay, the shape of basin thing is fully clear to you all. Now we'll discuss the size of basin. Yes, very good. Very good. I hope you have written it also. Now we'll discuss the size of basin. Okay, so I hope you have written it. Okay, now we'll discuss. So the first factor which is shape of basin is fully clear to me. Now we'll discuss the next factor which is size of basin. Okay, now we'll discuss the next factor which is size of basin. So in size you need to understand it's a very simple factor. Okay, let us assume, now we'll discuss size of basin. So let us assume we have a small catchment area and we have a bigger catchment area. Let us say we have a very huge catchment area. Let us say this is a very big catchment area. Can you guess where water will drain quickly? Small or large? Comment everyone. And let us say we have a smaller catchment area. Okay, let us say we have a smaller catchment area as compared to a large one. Okay, so can you guess where we will have a quicker drain off? Sir, that's very simple to understand. Okay, sir, in this one you will see, sir, I will see that it will take too much of time. Water will take too much of time to reach the outlet. So the graph will be like this. Okay, it is taking too much of time. Sir, base time is very long. Okay, the entire catchment will start contributing to the outlet flow in a very long time, and peak discharge is less here. Okay, this is your peak discharge, that will be less. So in the first case I have lesser peak discharge and more base time because it is taking too much of time, because catchment is long, so obviously water will take time to reach the outlet. And here in this one what I will observe? Sir, I will observe a sharp peak or a higher peak. Peak discharge will be more and base time will be less. What I will observe, sir? Sir, I will observe that peak discharge is more and base time is less. It will drain quickly. Yes, very good. Simple. This is your size of basin. So is this thing clear? So in smaller basins drain off water quickly. Yes or no? So I will write one point here. Smaller basins drains off water quickly. Okay, so this was your second factor. Now we'll move on to the third factor, which is your slope of catchment area. Shall we proceed? So have you written this one? And vice versa. Smaller basins drain off water quickly and vice versa. Okay. Now we have to discuss slope of basin. Okay. Now we have to discuss our slope of basin. The third point. Okay, sir. Now we will discuss slope of basin. Okay, so we have two cases. Sir, we have two cases. Sir, slope can be sir steep. Yes or no? Sir, my catchment area can have a steep slope or it can have a mild slope or a gentle slope. Okay. Sir, it can have a steep slope or it can have a mild slope. Now guess where it will drain off quickly. When it have a steep slope. So let us say this is our catchment area and this slope is very, very steep. Okay, this valley is having very steep slope. So water will quickly go into the river. And ultimately reach your outlet. So when we have a steep slope, sir, then obviously in that case water will drain off quickly. Yes or no? Perfect. Great. Sir, when we have a steep slope, then water drains off quickly, base time will be less and peak discharge will be more. Okay, this kind of graph I will see a sharp graph. Where peak is more, base time is less. But when we have a mild slope, it will take too much of time to drain off. Okay, sir, it will take too much of time to drain off and therefore the peak will be less. In this case, the graph will be somewhat like this. It will take too much of time and it will be gentle. Okay, the peak will be less. Base time is more. Okay, base time is more. So I hope this thing is clear. This is simple point. This is simple. So this is the slope of basin. So size, shape size, shape and slope, all the factors are clear to you? Okay, perfect. Okay, size, shape and slope is clear to you. Now after this we have drainage density. Only 5 we will discuss. Only 5 are important for us, which from which questions can be framed in examination. So we will discuss only those 5 factors. Okay, size, shape, slope. Now is the drainage density. See, let us consider, sir, let us consider two basins. Okay, so this is your first basin. This is our first basin. Similar shape. See, the shape, size, and everything else will be same. Let us imagine. Let us imagine we have a catchment here. Let us imagine same catchment is here also. Okay, let us imagine same catchment here also. Same catchment. I have tried to draw same catchment, but yes, it is different, but no worries. Area, shape, size, slope, everything is same. But one thing is different. Sir, in the first catchment, you are seeing too much of streams are there. Too much of drains are there. Okay, too much of drains. Okay, too much of drains are there in the first one. Small drains. Okay. Too much of drains are there, sir, in this one. The first one. Okay. This is outlet. But in the second one, so the tributaries of your main river or the number of drains are less as compared to your first case. Can you guess what will be the difference? Can you guess what will be the difference between them? So first thing, what is the meaning of drainage density? Exact meaning of drainage density is, okay, now tell me where water will drain off quickly. Sir, obviously in this one. Sir, obviously when I will draw the graph for this one, I will see that water will drain off quickly. Okay, peak will be more and base time will be less. Peak will be more and base time will be less. And here sir, since water will take time because drains are less, so it will take too much of time to drain off, too much of time, and peak will be less. Yes or no? In this case, peak will be less. Why, sir? It will take too much of time. See, imagine after rainfall in your city, you must have seen sometimes, you must have seen definitely that uh, after rainfall, sometimes water gets locked in your area. Okay. Why? Because drains are choked. When number of drains or drainage density is not proper, or you can say when drains are blocked, you will see water will get locked up and it will very slowly it will leak, or very slowly it will drain off, and it will take too much of time to drain. This is the case. Okay, and this is the case when you have proper drainage system, when number of drains are high and they are very clean, so immediately all the water will gush and it will reach your main river, and immediately all the runoff will occur. Okay, is this thing clear? So this is your, now sir, exact meaning of drainage density is, see, the drainage density means, if someone asks you like what is the definition of drainage density, you will write the drainage density means the total length of all streams, the total length, okay, the total length of all streams, the total length of all streams per unit catchment area, or you can say the total length of all streams divided by the catchment area. That is drainage density. The total length of all streams with respect to your catchment area, or you can divide it by the catchment area, that is indicating your drainage density. Density means more the number of drains, more the length of drains. Okay, more the length of drains, higher the drainage density. Okay, so the total length of all streams per unit catchment area. Now in both the cases area is same, but here you can see more length of drains are there. Okay, if you will add up all the lengths, that will be more. So that is drainage density. What is stream density? What is stream density? If someone asks you like what stream density is, if someone asks you what is stream density, so drainage density is clear to me. If someone asks you like what stream density is, you will say, see, this is the total length of all streams. This is the total length. That will be total number of, see, you can see in this, we have first stream, second stream, third, fourth, fifth, like this. We have many streams here. Okay, we have many streams here. So I can say stream density means the number of streams, the total number of streams. Okay, number of streams. So stream density is what? The total number of streams, the total number of streams per unit catchment area. Okay, per unit catchment area. So let us say we have 54 streams total in your 100 kilometer square area. So this is what? This is your stream density. This is your stream density. Okay. Tell me, stream density thing is clear to you? So we have discussed 4 factors till now. So we have discussed 4 factors till now. More number of drains, more the length of drains, faster is the drain off. Okay, faster is the runoff, and you will see that water will drain off quickly. Okay. Now the last factor of catchment area is land use and cover. Okay, I hope you have written all these things. That see, drainage density definition has been asked in GATE examination once. Okay, so drainage density you should remember. Then we have stream density. I've written both the definitions so that you don't forget it. Okay, sir. Now last factor is your, see, this was your 4th one. Now the 5th one. 5th is the last one. 5th is the last one, which is your yes, land use and cover. See, I want to ask one question from you all. See, we have 2 kinds of area, urban and rural. Imagine we have let us say we have 2 kinds of land masses. Okay, we have 2 kinds of land. First, land is barren. Barren means it does not have any kind of vegetation, or you can say shrubs, plants. It's barren, sir, completely barren. And the second, which is having too much of vegetation, forests are there, greenery is there. Okay, so can you just guess where runoff will be more? Can you just guess if both the areas receive same kind of rainfall or exactly the same amount of rainfall, where runoff will be more? Can you guess it? Where runoff will be more? Tell me. I am seeing your comments. Where runoff will be more? See, you need to understand, if I am drawing hydrograph for both of them, I will see where runoff will be more. Sir, in forest area, runoff is less. You have already told me, sir, in forest area, runoff is less. Why? Sir, whatever water will fall will remain there, because runoff cannot happen, because the forest or trees will obstruct, will retard the runoff, or will slow down the runoff. Yes or no? So in forest area we have less runoff, and in barren areas we have more runoff. This concept we have already discussed. And here, sir, infiltration will be less, because in barren area all the water flows away, and the water which has to go into the you can say soil, that is less. Okay, and here in forest area, because of afforestation, or you can say in tree area or in forest area, I will see that infiltration is more, and because of this infiltration, soil moisture, groundwater, all these things are recharged or replenished. Okay, now, so obviously when we have more runoff, it will be rising quickly. My flood hydrograph shape will be steep. Yes or no? And in this one, it will be mild. Yes or no? This is the difference. Let us consider a rural area and urban area. Let us consider urban versus rural. Okay, tell me where we have more runoff. Sir, obviously we have more runoff in, tell me, in urban or rural area, where we have more runoff. Can you guess? Can you guess where we have more runoff? This is the last factor of your catchment characteristics. After this, we have to discuss rainfall characteristics. Okay. So tell me everyone. Yes, you are saying urban. Perfect. Sir, urban areas have more runoff. Urban areas have more runoff, but lesser infiltration. But we have lesser infiltration, and rural areas, and in rural areas, sir, runoff is less and their infiltration is more, because more area is open, concreting is less, development is less, more you can say less concreting is there, so more water will go inside the ground. More water will go inside the ground. So if you will see the graph, urban graph will rise sharply, but the rural graph will rise slowly. Okay, so this is the flood hydrograph for your rural area, and this will be for your urban areas. Okay, so if your land use is different, okay, if land cover is different, okay, we can have 9 types of land uses basically. Sometimes we have forest, sir, sometimes we have farms. Okay, forest is there, farms are there, unused farm or fallow lands are there. So like this you have different land areas. Okay, so I hope this thing is clear to you. So I hope these factors are clear to you. Now we'll discuss, now sir, we will discuss storm characteristics. Now we'll discuss storm characteristic. Now first one is intensity of rainfall. Okay, now we have to discuss, see, we have discussed till now all the catchment characteristics. Okay, these were catchment characteristics, all these were catchment characteristics. Now we'll discuss storm characteristics. So let me write B point here. All these will indicate my storm characteristics. Okay, in storm characteristics, the very first factor is intensity of rainfall. The very first factor is intensity of rainfall. Sir, you need to understand, let us say duration of rainfall is constant. Let us say duration of rainfall is constant. We have two rainfalls, but both have happened for constant duration. Let us say for 2 hour. We have two rainfalls of 2 hour each. But sir, one is having more intensity. Sir, one is having more intensity and one is having less intensity. Sir, intensity can be higher. Intensity of rainfall can be higher, or intensity of rainfall can be lower. Okay, what is the meaning of intensity? Sir, intensity means the total depth of rainfall with respect to time. If amount of rainfall, if volume of rainfall is more in a given amount of time, I will say it is more intense. Yes or no? But I am just considering the case where duration of rainfall is constant. If I want to, okay, if I want to check them, hello Deepak, if I want to compare them, if I want to compare two rainfalls which are having different intensities, see, sir, you need to understand, if we have more intensity of rainfall, then obviously in that case peak will be more. Yes or no? In this case peak will be less. Tell me why, sir? Why peak is more? Because the total volume of rainfall is more, and if total rainfall is more, you will say direct runoff is more. Yes or no? Direct runoff will be more. So I will say that in this first point, volume of direct runoff will be more. Volume of direct runoff will be more. Yes or no? And here sir, volume of direct runoff will be less. Okay, so for a constant duration, if we have constant duration, let us say we have intensity 5 centimeter per hour, and let us say we have intensity 3 centimeter per hour. So obviously in this one, the total volume of direct runoff will be more, but the duration of rainfall is same. If this rainfall happens for 2 hours, this rainfall also has to happen for 2 hours, then only we can compare. Okay, then only we can compare. So this is your intensity of rainfall. Okay, so if you need to understand, if I1 is more than I2, if I1 is more than I2, then obviously in I1 case I will have more peak and more volume of direct runoff. Is this thing clear? Is this thing clear? So this is your storm characteristics. This is your storm characteristics. First point. So peak and volume of runoff is proportional to I. Is proportional to I. Okay. Clear? Sir, I can say that peak and volume of direct runoff and volume of direct runoff, sir, are proportional to I. Sir, 100%. 100%. Now the second point. Now the second point is duration of rainfall, sir. Now the second point is duration of rainfall. Tell me, sir, duration of rainfall. See, duration of rainfall, if we are having two kinds of rainfall, let us say we have one rainfall which is, let us say, which has happened for 5 hours, and let us say we have another rainfall which has happened, let us say, for 3 hours. We have two rainfalls. First has happened for 5 hours and next one has happened for 3 hours. Understand? See, if we want to compare them, we have to make sure that intensity is same in both the cases. Intensity means, let us say intensity is 2 centimeter per hour. Okay, see, this 2 centimeter per hour rainfall will happen for 3 hours also and will happen for 5 hours also. So we will make intensity constant, then we will compare. See, when we are comparing some other factor, then we have to make sure we are making other parameters constant. Okay, so here I am writing one point for constant intensity of rainfall. For constant intensity of rainfall, if intensity is constant, sir, if intensity is constant, then duration can be more or less, and based on that I will compare the peaks of hydrograph, I will compare volume of direct runoff, I will compare the duration of runoff. All these things will be compared. So for constant intensity of rainfall, for constant intensity of rainfall, you need to understand, for constant intensity of rainfall, the peak of hydrograph, the peak of flood runoff hydrograph, and the peak of flood runoff hydrograph and sorry, duration of runoff and duration of runoff and duration of runoff and duration of runoff depends on duration of rainfall. Depends on duration of rainfall. Okay, depends on duration of rainfall thing. This you need to understand. Then we have effect of aerial distribution of rainfall over catchment. Then we have effect of aerial distribution. Third point. See, you need to understand, if we have more duration of rainfall, then obviously the peak and duration of runoff will be more. Okay, you need to understand one thing. Sir, the peak of runoff and the peak of hydrograph and your duration of runoff how long this runoff will exist, basically base time we are talking, that depends on for what time or till what time my rainfall is continuing. What is the duration of rainfall over here? Okay, or simply let me write D. Intensity is denoted by I and duration of rainfall is denoted by D. So this is your second point. This is your second point. Okay, so this is the second point. So I hope you have written this. Is this in clear? Tell me if these 2 points are clear. Perfect. Now we'll discuss the last 2 factors for storm characteristics. Okay. Okay, sir. So this is storm characteristics is very clear to me. Now we will discuss the effect of storm movement, or you can say, see, basically we have to effect of aerial distribution of storm. See, let me write here like this. Effect of aerial distribution of storm, and the last factor will be direction of storm movement. Okay, direction of storm movement. Okay, so we have to compare them. Sir, we have to compare them. See, in the first case, let us imagine we have catchment areas. Okay, similar catchment area. This is your first one, and let us say this is your second one. Same kind of catchment area we have. Let us imagine. Okay, so let us say we have same kind of catchment areas. Sir, this is your main valley line of central river. Okay, sir. This is your, sir, central line, main central stream. Same kind of river pattern, same kind of rain. All the things we have considered same. Now, let us say in this area, rainfall has, see, this is your outlet. Wait a second. So let us consider this is your outlet. See, in this area, consider rainfall has happened in the, you can say, farther area. Okay, let us say rainfall has happened only in this area. Water, or you can say precipitation, has occurred in the far area, in the area which is farther from your outlet. Okay, in the back portion, which is farther from your outlet. But here in this case, let us imagine, here in this case, the aerial distribution of storm is such that it has fallen, water has fallen, or you can say precipitation has occurred in this area. So tell me where you will have quicker peak. Sir, when I will draw the hydrograph, for this one, see, I will draw hydrograph for both of them. Obviously, I will draw hydrograph for both of them. For the first case, I will see, sir, water will take too much of time to reach the outlet. Yes or no? Water will take too much of time to reach the outlet. So when it will take time, so obviously I will see that in that case peak will be delayed. Sir, I will see that in this case, sir, peak will be delayed like this. Peak is coming but later. But here, sir, since water, the area which is closer to the outlet has received the rainfall, I will see that peak will be arriving quickly here. Yes or no? Here I have quicker peaks. So this is the difference. Okay. So this is the effect of aerial distribution of storm. Obviously, if different areas are receiving if different areas are receiving storm, or you can say if storm is distributed area wise differently, then in that case obviously the shape of hydrograph will change. Okay, so what kind of aerial distribution? Aerial means area wise. Okay, so in what area precipitation has happened? Is your area closer to the outlet? Is your area farther from the outlet? If the area which is farther from the outlet has received the rainfall, then obviously it will take time. Then obviously, sir, it will take time. Yes or no? Yes or no? So I can say, sir, here time to peak is more, and here time to peak is less. Now the last factor. Now we'll discuss the last factor. See, direction of storm movement. So again, let us consider we have same catchment areas. Again, sir, let us consider we have same catchment areas. Again, let us consider, sir, we have same catchment areas. Okay. Sir, but now what is happening? Now what is happening, sir? We have a cloud. Okay, I will draw it with different thing. Sir, we have a cloud. We have a cloud which is moving towards the outlet. Okay, and sir, here we have a cloud, and here we have a cloud which is moving away from the outlet. We have a cloud which is moving away from the outlet. So direction of storm movement means, is my storm moving away or towards the outlet? Yes or no? Direction of storm movement means that where my direction of storm movement means where the storm is moving. Sir, if it is moving towards, then obviously we will have quicker peaks, and if it is moving away, then obviously the peak will be delayed. Yes or no? Then obviously the peak will be delayed. So I hope all the points are clear to you. So these are all the factors which we have discussed beautifully. Okay, so tell me now if all the points are clear to you. So if we will summarize, we have discussed today direction of storm movement. Okay, we have discussed the effect of aerial distribution of rainfall. Okay, so if your area which is closer to the outlet, if it will receive the rainfall, then obviously you will have quicker peaks. Then we have discussed intensity of rainfall. We have discussed duration of rainfall. These are the storm characteristics. Then we discussed the effect of land use cover. Okay, we have discussed intensity of rainfall. We have discussed effect of duration of rainfall on shape of hydrograph. So these were different factors which we discussed today who will affect the shape of hydrograph, slope, drainage density. All these things affect size of basin, sir. Size of basin, and then the shape of basin. The very first one is shape of basin. So these were the different factors. These were the different factors which will affect the shape of hydrograph. So I hope all the factors are very, very clear to you. In the next class, we will start volume of direct runoff, which is very, very important. Okay, volume of direct runoff is very important, and many numericals from that topic has been framed in your past year papers. Okay, in previous year papers, many questions have been asked from your volume of direct runoff hydrograph thing. Okay, so we'll discuss that in the next class. Next class will be very, very important. Okay, so tomorrow is Saturday, so obviously there will be no class, but I will try to take class. If there will be class, I will let you know, because one day class was not there. So I will try to ensure that tomorrow there is class, so that proper content is being received by you all. Okay. Okay, so these were the factors that we discussed today. Okay, so we'll end our session today, and we'll catch up either on Saturday or on Monday itself. Okay, so thank you everyone, stay blessed, and one request to you all, everyone solve previous year questions. Okay, everyone try to solve previous year questions as many as possible. Okay, because only that thing will help you out. So practice more and more questions, and till now whatever notes we have made or whatever PDFs you have collected, revise them. Okay, revise them and solve your previous year questions. We'll catch up on Saturday or Monday. Okay, so stay blessed, take care.